Welcome, everyone. Warm welcome. Thank you for being here. Get yourself ready. You can grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a problem from the 1990, yeah, I know, it's a while back, BC exam. And here we have an interesting function. Bit of a almost paradoxical set of conditions that they give us here. So they tell us f and g are continuous functions with these following properties. G of x is some value a minus f of x. So they're closely related, their derivatives are closely related. A is some constant. They tell us that the integral from 1 to 2 for f of x is the same as the integral from 2 to 3 of g of x, okay? And the integral from 2 to 3 of f of x is equal to this negative 3a thing. So this a comes up a couple times. Go ahead and give yourself about 12, maybe 15 minutes to work this out. If you're an A-B student, you can still solve this. It is doable. And then when you're ready, come back. See how we do it here. Maybe you'll have a better method, or maybe you'll learn a little bit about my method. All right, let's get started. Part A. Part A wants us to find the integral from 1 to 3 of f of x, but we're going to be putting it in terms of a. Of course, this is because the integrals here involve one another of f of x and g of x, and they also involve a. So the integral from 1 to 3, well, of course, that's just going to be broken up into two parts. That's 1 to 2, and then it's also 2 to 3. So here we go. I'm going to say the integral from 1 to 2 of f of x plus the integral from 2 to 3 of f of x. And we already know what this part is equal to. This part is equal to negative 3a. Whereas the integral from 1 to 2, that we're going to have to rewrite as the integral from 2 to 3 of g of x. And then we have minus 3a. Well, since g of x is equal to a minus f of x, really what we're doing here is we're saying the integral from 2 to 3 of a minus the dx minus the integral from 2 to 3 of f of x. But then we had added the integral from 2 to 3 of f of x. I noted that it was equal to negative 3a, but I think it's just more clear if we simply cancel these right here, right now. And the integral from 2 to 3 of a is simply going to be 1 times a, or just a. So it's definitely in terms of a. No doubt about that. Part B, find the average value of g of x, and it, of course, will be in terms of a over the interval from 1 to 3. So first we're going to write out the average value formula when we're using integrals, which is 1 over b minus a times the integral from a to b, f of x dx, or I guess in this case it's going to be 1 over 3 minus 1 times the integral from 1 to 3 of f of x dx. And we just did the integral from 1 to 3. Oh, sorry, this is g of x this time. So here we're using g of x. Yeah, that seems more appropriate. Okay, so this is going to be equal to 1 over 2 times Well, since g of x, we're going to have to use this definition of it again, is equal to a minus f of x, then we can just replace that with the integral from 1 to 3 of a minus the integral from 1 to 3 of f of x, and that's the part that we've completed already in part a. So this is going to be 1/2 of a times 2 minus this integral, which we already determined was a. So this is just going to be 1/2 of 2a minus a, so just half of a, or a over 2. Pretty straightforward. It seems, maybe a little uncomfortable to try to carry out some calculus and make substitutions when there's parameters like a that are missing. But just trust the math, trust the process of these fundamentals, right? Using substitutions where appropriate. If we get stuck at g of x, turn it into a minus f of x. And then look for where we might have answered parts of this question in the past. Okay, let's move on to the final part, part C. It says find the value of k. Oh boy, now we have another parameter, k. If we know that the integral from 0 to 1 of f of x plus 1 dx is equal to ka. So this one is a little bit tricky because we need to rewrite the expression. We don't really have any information about from 0 to 1 at all, so that's your first clue. But then we have this x plus 1 thing here. So really what we kind of are doing next is we're going to make like a little U-Substitution. U equals x plus 1, which means now our limits, and du of course is just dx, so that differential stays the same. But the limits of integration here are going to go from 1 to 2. And it's kind of like f of x dx, but instead we're using u, so this is f of u. And we're saying that this is equal to k times a. So the integral from 1 to 2, this is going to be equal to, according to that second definition, or that second condition, this is integral from 2 to 3 of gx. See how I'm just substituting that. Basically the same thing. I think it should technically be gu du, but same. It really, yeah, let's change it just because the math part of my brain is like, hey, you can't do that. So this is going to be equivalent to integral from 2 to 3 of a minus 2 to 3 fu du. So this again is just going to be 1 times a. Now remember, this 2 to 3 for f, that is also given. That's the third condition. See how we're just really, when we get stuck, we just use one of the conditions to get us unstuck. That equals negative 3a. So we have to be careful here. Minus a negative 3a. Yeah, being very careful with that minus. So this is just 4a. And if this equals ka, therefore k equals 4. Okay. Okay. Maybe I can say a-okay. Yeah, no, that was kind of cheesy. So this function, this problem gives us two functions that are related to each other, but we don't have any idea what their equations actually are. And we're given these seemingly random, misplaced conditions here, certain values, and how to change from f of x to g of x and back to g of x and f of x. But really, we're asked some pretty straightforward questions because of that. We're asked for the integral from 1 to 3, the average value, which still involves the integral from 1 to 3. And then part C, I would say, is the trickiest because we have to use a sort of a U-substitution, or a shifting of the function and the limits of integration to finish that one off. Okay, so even if we're not given an equation, a lot of times we're still expected to be able to do calculus. And this was definitely something that was emphasized more in BC back in the day, according to what I've noticed doing a lot of these really old problems from before I was even born. I can tell that in BC they were really expecting you to understand how functions interact with each other, rather than just merely testing your derivative rules and quotient and product rules and such. It was a little more abstract than that. So I hope you got something from this problem and followed along. It was a bit of a short one, I have to admit. And yeah, that's enough blab out of me. I'll catch you guys next time in the void.